ladies and gentlemen. It's a pleasure to introduce to you Rafał Krawczyk from Warsaw University of Technology. And he's here because of a project which we started 3 years ago, control and regulation of animals' behavior using neuro or optogenetic methods, or neuroengineering in general. And this project was a try to, from my point of view at least, apart from interesting scientific questions which could be answered, like what are or how to control, is it possible to control behavior of animals? Well, it's known that it is possible, but whether it's possible, for example, to control mice or to prevent them from falling again into alcoholic disease, using methods which are generally called optogenetics, and which it basically amounts to a technology which allows to turning off certain parts of the brain. And indeed, it's hoped that if you are an alcoholic and you have a pilot finally, and you go along your favorite drinking place, you just turn off a part of your brain and you are safe, right?
Also, if we sit in a cage, we are safe, right?
Yeah, that's true. No, but that's a prize that we are still on a level of experiment on mice in cages. However, of course, a part of that, as you understand in Poland,
mice is alcoholic?
well, because there are many people. I mean, alcoholic disease is something like 700 billion euros per year cost in European Union. So, you know, reducing 10% and turning 10% of those 10% into science, for example, will improve conditions of many people, including ourselves. Yeah, but let me also stress that what was extremely important in science is also about that, finally, to break a lot of barriers in collaboration between various institutions in such a way that in the future there will be a smoother collaboration, or we can profit more from synergy between very good people who are at electronic or faculty of electronics and very good people in Institute for Experimental Biology and very good people, for example, in Center for Theoretical Physics. And that's another part of this project, just to give ourselves a chance to provide such a, or to perform such a research. So that floor is yours, and that particular collaboration resulted recently in a very nice paper. I sent you a link, and it's impact factor 8.
Thank you very much, Professor. Good morning, ladies and gentlemen. My name is Rafał Krawczyk, and today I will talk, as Professor said, about a very interesting collaboration between our institutions that led to providing very interesting tools for basic studies. So I think that this presentation may be very informative about the forms of collaboration that provide new methods of investigation of several occurrences in biology that are enabled by strict cooperation of electronics, physicists, computer engineers and biologists. So, just to give you brief information what kind of collaboration it is, there are 4 institutions involved. First of all, the Center of Theoretical Physics of Polish Academy of Science, Institute of Electronic Systems, Warsaw University of Technology, Nanski Institute of Experimental Biology, and University of Warsaw. I will give you the information what actions have been taken by each of these facilities, but let me introduce the agenda first of all. I will present a brief overview of scientific issues and the problems that we are trying to overcome in this specific fields of study. Second of all, I will discuss the augmentation of the functionality of the operations that are taken in this fields of study and what we are actually trying to extend in the specific fields of research. Then the issues that we had to overcome and we faced, because let me assure you that that specific investigation is strongly research and development, with lots of trial and error, some of whom were really promising, some of whom had to be at least temporarily abandoned. And in the end, as I mentioned, our end user will be the biologists. So our main objective is to prepare tools that will be used by biologists in brand new experiments that will lead to that will be the result, the final ultimate goal of the research, which is providing new methods to make brand new research in the optogenetics. Now, to give you just a brief information, what is optogenetics? Well, it's a relatively new field of science. I think it has not more than 15 years, and it is enormously attractive. As you can see, lots of prestigious publications have been done so far in this specific field of study, and lots of really interesting findings have been so far done in this specific field. Just to give you the definition, but let me focus on the most important thing. First of all, according to Scientific American, it is the combination of genetics and optics, which is, as I will show on the next slide, infecting the organism with light-sensitive cells. I will show you it in a moment. Why do we do it? By delivering light into organisms, we can excite the neurons later on and force organisms to react in a specific way, which to some extent is really interesting. Now, the methodology. First of all, we have to infect the mammal with the virus that will infect the neuron with the light-sensitive cell. Later on, which has been done so far, but we try to extend it, we then connect to the fiber wire to the mouse, and then shine with the light into specific neurons in order to excite them and to force specific behavior in the animal. Now it may seem simple, but believe me that in order to target specific neurons, we first of all have to know where the neurons are, which neurons in particular are responsible for specific behavior in the brain. So that is quite a comprehensive research. First of all, by using the tomography method to find these specific cells, and then to scientifically prove that these behaviors, that these specific neurons are responsible for these behaviors. Now, what has been done so far?
Can I ask a question?
Yes.
Well, could you go back?
Yeah. Yes, please.
If you inject the virus into a particular neuron, how do you know you are not changing other properties of this neuron? These are not neurons arbitrary. They play a certain role in the structure of a nervous system of the mice. And if you infected them with a virus, the question is, do you change the original behavior of the neuron or not?
Let me answer this question. This
answer is irrelevant to my question.
Yes,
because the question is that whatever you do with the neurons or its connection, the question is, does that affect the normal activity of that particular setup? And that is a simple question. Does it or not? Whether it penetrates the brain.
I want to answer your question, but I need to introduce. So, once the virus was injected, it affects only new cells. So the answer is yes, but only. So there is a time window of 1 or 2 hours where newly created neural connections are affected and are equipped with photosensitive cells. And after that, this particular neural connections for the lifetime of animal are sensitive.
But that was not the question. The question is that for that particular period of time when this injected with the virus neuron or a neuron connection is affected.
Yes.
And then
Well, and it doesn't work the way it worked before or after. The question is, then you can do your experiments on the then, when it's active, when you connect that wire. How do you know that this is a response of a neural network of a mice or of artificial structure which was caused by the injection of
No artificial structure is.
There is, because you injected the virus. And
No.
as you said, this is a
The
different neural
virus
connection.
the virus itself does not interfere with normal brain function. It activates only when light is applied. So when there is no light, there is no change in the behavior.
Now, how do you know that? I mean, the question is that this is a certain chemical structure, and a virus is a huge molecule.
Yes, but
can you do the experiments on that connection, this neural connection, without introducing the light, to prove that
Yes.
this connection works exactly the same
Yes.
as with before?
it's well known.
That's the answer to my question, not whether it penetrates or not.
Thank you. Well, now, what has been so far done in this specific field of study? First of all, one of the most interesting discovery was and widely announced was the set of neurons responsible for overeating, which can be easily Googled. Unfortunately, I don't have any access to the internet, but should you Google the information neuron for overeating discovered, you will find numerous movies in whom the mouse is not hungry, but when the light is introduced, she has to eat. So it is one of the most known discoveries in the specific fields. But as Professor mentioned, there is a plethora of behaviors that can be investigated in this specific area. First of all, the fear, hunger and overeating, then addictions, as Professor said, the alcohol in particular, other diseases as epilepsy and how can it be hindered, and what we are also targeting, the social behaviors, which so far has not been that trivial to conduct. I will then discuss why. But first let me tell about the environment.
Just one remark. Basic, that is, the method works like that when you turn on the light, it polarizes the molecule which was artificially inserted by virus into a neuron. This molecule becomes, there is creates additional electric field, and this electric field blocks the neuron action. So what you can do, you can just switch off certain neurons, right?
Actually, you can either switch off or activate, depending on the light wavelength.
Depending on the frequency, and there are also the wires that are they can do both, turn on and off. Now, let me tell something about the environment in whom the experiments are conducted, because it is also of importance in this research, which is the home cage environment. It is a specific form of a cage for animals in whom there are introduced sensors that allow to conduct the research and to some extent see and focus on behavior on the mice. For instance, there is available on the market, and we are using for evaluation and development purposes, so-called the IntelliCage. It is the cage with 4 corners in whom you can observe whether or not the mice have entered the cage or have taken specific actions, such as entered the corner of the cage, entered through a specific door, or started, for instance, to lick the liquid introduced into the cage. However, several issues are associated with these cages, and these are of importance when you consider the experiment from engineering point of view. First of all, such an environment has to be reactive, because not only it does collect data, but it reacts to specific combination of behavior in a specific way. For instance, when you want to teach the mice that not to enter the corner, or not to enter the corner in specific conditions, there is, for instance, a blow of the air that may scare them. Now, to introduce the blow, you need to program the device to react for specific behavior. Now, this response of the system has to be done fast enough in order to make the experiment relevant, because the mouse has to know that the action was due to her behavior. Now, considering also the monitoring, some functionalities from the, as I mentioned, from the computer engineering point of view has to be done. First of all, the collection of data. Second of all, allowing the end user, who is a biologist, to program actually the device in a simple way. Now, to allow continuous monitoring of and collection of data, which varies depending on the level of complication of the experiment. And then, as I said, to provide a responsive environment. Now, as I mentioned, the IntelliCage provides the way to program the experiments, which is done in this block structure, and this is by using this blocks you can create using a graphical programming language. You can develop an experiment and later on to monitor. However, this cage has specific limitations, and the software has allows to the diagnostics to some extent, and we are trying to augment this functionality in order to allow biologists to make a more comprehensive investigation, to focus on larger number of sensors, which we are currently trying to introduce to the our own proprietary cage that augments the augments what IntelliCage has to offer. Now, as I mentioned, new functionality. So, what can be done in this cage? What can be extended? What is in high demand from the point of biological experiments? First of all, going wireless, and I will justify why we are doing this, why we want to conduct the experiments without the fiber wire attached to the mouse. Then, detecting position, which hasn't been done so far, because we can assess whether or not the mouse is in the corner, but we cannot say specifically that in this very moment she has this specific position in the cage and give it the coordinates of the position. Now, another important supposition of the research that we are undertaking is to combine both optogenetics and home cage environment research into a tighter, more unified form. And then, what I also mentioned, the investigation of social behaviors, which has been strictly hindered so far when considering optogenetics, we are trying to allow us. Now, excuse me. Now, why are we trying to go wireless? As you, I guess, will have realized, the fiber wire is a quite visible device that just sticks out of the mouse and has to be let out of the cage. Now, when considering the large number of mice, well, usually they do not like when something is sticking out of them. And when there is a group of animals, yes, when there is a group of animals, this is extremely likely that another mouse will try to just chew off the devices that stick out of the other mouse. So we are trying to provide the devices that will not be visible to another animals. They have to be small. Another thing, and that was the major factor when the social interactions were considered, because it didn't allow actually the optogenetics in investigation of social behaviors, which was a major drawback. Now, what does it induce? First of all, as I mentioned, we are trying to get rid of the cable. Second of all, when we try to achieve it, we have to focus that the implant will be small and injected in such a way that it will not be visible, it will not be it will not be spotted by another mouse, which is also of importance, and it has to be, is also a huge benefit of using small implants, is that, as you can see on the picture, the methods that have been used so far use a huge implants that look like a helmet on the mouse. Without that, we will also allow the experiments to be done in such a way that we also how to say it, we create an environment more similar to what happens in a normal natural environment, because there are no huge devices on the heads of the animals. They are almost or absolutely not visible to other animals. Now, considering the hardware and software, which is our particular point of interest in this research, what has been introduced to in the framework of the investigation? First of all, there is a patent application that has been already prepared and is under scrutiny by the patent office, which is the EcoHub, Eco-Habitat, which is a cage specifically designed to investigate social behaviors among the group of mice. It has been designed in order to, first of all, as I said, investigate the interactions between animals, and several devices, sensors, have to be put in the cage in order to allow this. What can be seen here is that cage also consists of 4 separate chambers connected with tubes, which is also a novelty, but introduces several issues from the engineering point of view. Now, what has been introduced, what electronic supports has been introduced for the Eco-Habitat? First of all, excuse me, a comprehensive system for diagnostic has been developed in order to acquire data from the various sensors and to connect to the NPC, which will be controlled by the end user, who is a biologist. In here you can see the mini rack. excuse me, mini rack consisting of the several boards that will be responsible for collection of data, communication with the PC, and the responsive functionality of response, the function of the response of the system.
And these sensors have their own power supply?
Depends which, because the ones done in the cage are will be all powered either from the rack or by their separate power supply. But the sensors that will be mounted on the mice will be powered wirelessly by the system, and this is one of the assumptions of the research, because in order to make implants on mice small with their sensors, we have to withdraw from using a battery. Yes, which is also
To store the energy.
we have to provide continuously energy to it.
But then how do you know you will not transform that energy to the animal in another way than through this sensor? I mean, if the mice moves,
Mm-hmm.
I mean, normally wireless transformation, when you charge the phone,
Mhm.
we have the wire, right?
Yes.
It's localized.
Yes.
Now you want it delocalized. So the certain intensity, enormous intensity of that field will be all over the cage.
True.
And the mice will, that is not a normal environment of the mice.
Actually, the level of power which affects them out, it's small, it's a milliwatts.
But it's much larger than normal
But it's
energy of the field in which the mice lives.
It's low frequency.
We are being continuously told that the fact that we are living in a sea of electromagnetic field which is increasing energy that influence behavior or primitive systems. How do we know that that's not the fact? I mean, have you done the experiment with the mice without this virus injected cell, just in the cage which is full of such a tremendous amount of radiation as compared to the normal?
There are other cages which has RF field in it. They are available on the market.
One of the things which I remember from an early discussion about the influence of, the reason why I'm asking is that I remember from the early discussions about the influence of the cell phones on the humans, the experiments done in Boulder, Colorado, with a rat living in a cage filled with electromagnetic radiation, and the fact that the rat's tail serves as an antenna for a very particular kind of wavelength. And there has been a curious reaction of the rats, depending on whether they have the original, so to say, tail, or the tail was cut in a half or something.
They are working on a very low frequency. The wavelength is a few meters, tens of meters. So the size of mouse is so small that it actually does not interfere with it.
So what is that? So if you have such an enormous little wavelength,
Mm-hmm.
how do you? Then the mice is very small. So how this energy is then being? What is the mechanism of charging this, feeding the energy into this
The cage is
device?
in the, yes.
No, in the cage that I know, but in the head of the mice.
The coil and the wireless transmission. I mean,
If it's a huge wavelength,
Mhm.
then it's very long, then it's essentially constant over the length of the
Yes, but-
mice. So how do you
But
then?
apparently it works.
I'm just asking. Yeah, but I mean, if I accept that everything apparently works, then why should
Why
I
don't you
listen?
wait until it comes to that point? I mean, you are asking questions.
Yes, he will explain it.
First of all, this is a very active field of research. The question is,
I mean,
basic question was correct. I mean, how do we ensure that all this electromagnetic field does not influence mice in an uncontrollable way? Yes, it is a good question. Yes, it has to be studied. Nevertheless, we cannot study it before we complete construction of the cage
I
itself.
was just asking about the church. Okay,
Mhm.
go ahead.
But if you're interested, there has been a publication, I think 1.5 years ago, by University of Stanford that has introduced very trivial in comparison with our solution, but has introduced a method of wireless power transmission, and I think they do have some results which may be informative in answer to your specific question. So to continue with the presentation. Now, the implants, as I said, they have to be small and they have to be designed in such a way that you can both introduce them to the mouse as a set of coil lead put into the brain and the electronic implant, but also to do it separately, because biologists are considering both functionalities, and as I mentioned, it has to be considerably small in comparison with what has been done in contemporary research. As you will have seen, the implants are large in comparison with what we are what actually Greg has developed. Yes, we also focus on the minimalization. Now, the laser curtain, another device that is maybe considered as a sensor, developed by Paweł Rasiński, which is a curtain that will be responsible for investigation whether or not the mouse reacts to being by the smell attractant. And if there is a specific smell which attracts the mouse, we have to monitor whether or not it reacted to this specific excitement, and therefore the laser curtain is introduced and developed in order to focus whether or not the mouse has touched has passed through it with its nose or any other part of the of its body, in order to investigate whether the reaction to excitement occurred. Now, considering the position detection, there has been a lot of research considering this specific field, because it is one of the most important issues in this research, and several attempts have been made. Our first idea was to use a set of coils in order to just transmit signal and check its strength, but we now introduced a solution that may be that seems to be more promising, which is using the system in whom there will be 2 coils per dimension of the cage. 2 coils that will be powered on and off. Now, there is a magnetometer, and we have already with Mikołaj Sowiński from our institute made a proof of concept in whom we obtain a viable data and have shown that the position can be shown in such a way. Now, there is a magnetometer. Magnetometer is simply compass, and there are 2 coils. When powered, the strength of magnetic field can be acquired by the magnetometer, and by turning on and off coils in each dimension, we can, basing on the strength of the acquired strength of the signal, figure out what was the position of the mouse.
Magnetometer is installed on the mouse.
Yeah, it is mounted on the mouse.
Part of the subscription of this implant.
Yes.
So there is some magnetic component which is implanted in the mouse.
Yes, there is. Yes, the sensor.
Magnetic. 3-dimensional magnetic sensor. And once when we have coils which we actuate, and each pair of coils generates a magnetic gradient. And when we switch to the X and Y fields, alternatively we can detect the position of the mouse in the cage.
point is, yeah,
no, that's a very good point. But if
yes.
you have 10 mice in the cage, how you distinguish them?
And another factor.
Form like
Put
a
one red drop. Second, you can put a red dot on one mice.
But one is lying on the back, one is sitting on the other. But so you when they are
So
stuck.
you paint the mice.
Yes, but
No, alternative is to paint them. No, that's serious.
But
There are such ideas, but they're not work.
the point is that regarding the image detection algorithms, that they have a limited reliability, and they strongly, strongly depend, for instance, on the how the cage is, how the lighting is introduced into the cage. For instance, I have personally met a situation in whom the algorithm was working perfectly. Now it stopped work, and in the ultimate environment of testing, it wasn't working at all because there was a different lighting system introduced to the to the environment.
Experiments are often done in complete darkness.
Yes, which somehow limits the image. Yeah. Now, what issues have to be overcome, and what studies have been conducted so far? As I mentioned, it is an incredibly research-oriented study, and a lot of trials have been done, which some of whom proved to be really promising, but some of whom had to be not more evaluated. But what are the most important issues that are in this study? First of all, the power transmission was it has been discussed, and the trials that we have done so far. Now we have a reliable solution under construction, but it has taken us a significant amount of time to develop one. Now, another thing is the fast response. As I said, the system has to be responsive. Now, it may seem obvious when we have a working device that, well, when we, for instance, look at the IntelliCage that is available on the market. Well, it seems trivial, but now the system has new sensors, some of whom, especially the laser curtain, needs to have comprehensive algorithms, and having these comprehensive data processing, we still need to provide the responsiveness of the system, which renders the problem to be not as trivial as it was before, because like in the contemporary solutions, the amount of data is not that significant compared to our system. As I said, processing the data in real time. Now, the analysis, because not only we have to collect data, but we have to unify the data collection from different sensors, and to then excuse me, then to send them later on to the biologists in a format that allows them to analyze the data. Now, and again, in the framework of this requirement, we have to provide a unified, reliable solution for the experiments, and which may seem obvious, but again, it requires a significant amount of work put in it. The solution has to be robust. As you will have realized, the experiment with living animals is extremely demanding. Mice can behave in a absolutely different way depending on significant amount of factor. They move extremely fast. They can jump all around the cage on a whim. And to provide a solution that will be reliable, well, it requires a significant amount of work put in order to provide such a mechanisms. Now, what are we targeting? At the meeting approximately 2 months ago, we have established several experiments with the biologists that we are targeting. First of all, now we are trying to gradually test the functions that we have introduced in the experiments, not the ultimate experiments that will be done at the end of the research, because the experiments that we are targeting are we first of all have to test the environment. We have to provide an intermediate test that do not aim to provide a new research in the field, but have to first of all test the reliability of our solution. So several experiments are planned. First of all, as I mentioned, we are trying to test as the power transmission and entire communication with wireless communication with the implants in the mice. Second of all, we in the further steps are discussing about gradually introducing next sensors to the IntelliCage, and seeing how the when considering the feedback from the biologists, we will proceed with the experiment. So what are the experiments? There are three trivial experiments that are done so far, that are planned to be done. The test the implant experiment, in whom the implant is only few functionalities of the implant are planned to be tested. The idea of the experiment, I will maybe show it on the board. I think the cable will be enough. Okay. So the basic idea is to test the power transmission to the system, and there is planned to be used a cage in whom only half will be powered, or the entire cage will be powered. Without comprehensive data analysis so far, we are planning to test the reliability of power transmission and how the mice behave with the sensors, also to answer to your question. Now, with these experiments done, we will be able to assess how to introduce for further functionalities. Now, another step is to provide position detection, which is the second step of the experiment, and then having these two, we will then decide where to move with the further experiments. Maybe just to focus on the Echo Hub if it will prove itself reliable, or maybe just to enable several other experiments that will be not that fast available, just maybe to augment the IntelliCage where we have just developed a way to do, where we have developed a mature way to do it. Now, what to be solved? As I said, the power supply will be dissolved, and the algorithms that have to be tested when considering the power detection, because it is, as the method with the coil seems to be simple, some filtering and another data analysis has to be provided in between putting in the end the position and the collection of the data, and they have to be tested in the ultimate environment. Now, as I mentioned, the research is quite broad, and enormous amount of contribution has been done so far, considering hardware software development, consultations with the biologists, and the development of the experiments, and the provision of the sensors. So if you have any more questions, please be welcome. I will try to answer them. Thank you very much for your attention.
You have a drawing of our new cage under construction?
Not so far. I think that I.
There is a lot of effort going into this position type control, but that seems to be not connected directly with the main subject, which is optogenetics.
True, but the point is that when considering, I will try to answer these questions in a so when considering optogenetics, we try to turn on and off the optogenetic devices depending on some social behaviors. Now, when considering position detections, when we have the information of the position of the mice, we can, for instance, see that we're close to each other, and to monitor in what way they behave, and this can be this information can be used to trigger the turning on and turning off the optogenetic devices.
For example,
I understand it's important to see whether the mouse is nervous and is running around.
But
or
also
is
social
sleeping,
behavior.
or
This is from experiments in
That's
intelligence.
exactly what we
It
want.
is known that more mice fell back into alcoholic disease much faster if there is a one mice in the cage which is alcoholic and already, right? And so what they want to investigate is how much time they spend nose to nose, for example. So not only position is important, but also orientation of animals is important, right?
And this
Whether them turning on and off this light will change this proportion of time and so on, right? So basically, there are many behaviors which are enhanced by social interaction, but the precious, the exact way how it is done, it's basically unknown yet, right?
So, Rafał didn't say too much about the negative effects, but we have several challenges. For example, optogenetic activation requires quite a lot of power, 20 to 50 milliwatts when the light is on. So we have to deliver this power. If we want to introduce the battery to the mice, so standard lithium-ion battery would let us shine the diode for 10 minutes. We cannot put too much too quick battery. Maximum is something like 5 or 10 grams. Otherwise, the mouse would not like it, and it would simply inhibit it. Yes, that if you install the battery on the back of the mouse under the skin, and if the mice doesn't like it, it will ask another mouse to do the operation. It will cut the skin and eat this device. It's really tiny, so no battery can be used.
And I also didn't mention that in the project there is a person who is a specialist for the development and design of radio antennas in order to provide a reliable ways of transmitting the power.
So we conducted several experiments with power transmission, and it seems that the most suitable is low frequency of 27 megahertz, which is the ISM bandwidth, which is you don't have to use special permissions to use this frequency. And the receiving antenna can be as little as 6 millimeters in diameter. So to respond to question, we couple to the magnetic field, not to electromagnetic field. So we couple to the magnetic field of the transmitter, and we use coil around the cage, which gives quite unique uniform distribution of electromagnetic field inside. If you want to couple to electromagnetic field using standard antenna, the dipole would be several meters. But if you couple to magnetic field, then it's very, very little.
Just to give you information, in the present version we are developing, the cage will be inside of the cube in whom the coils will be installed. So there is a whole casing for the installation of cubes, and then the entire cage is inside.
We could show this 3D drawing of the cage.
I don't know if do you have one? Maybe I can.
Put on your emails.
Maybe I don't have the internet access.
Is
So, yeah.
optogenetics so far restricted to mice or other animals?
There are rats.
Mammals mainly.
Mammals, they also do.
Yes.
What about humans? Do you know?
How big is the cage?
I will show you the dimensions.
You have seen the picture, but
Yeah,
like that.
that's 25 to 25 centimeters for chambers, and this one is for 30 centimeters. 30 centimeters.
Probably
Yep.
what counts is the ratio between the size of the cage and the size of the mice. And that is
For elephants.
that is problem. For elephants, cell which is inside, to which it touches.
Yes, but
Which is all over a sudden a point heated inside of the brain of the mice.
Well,
The-
depends on what you are talking about. If you're talking about the implant, the light source which we slide inside.
No. The word is the cage has an electromagnetic field which
True.
as I
Okay.
there is a loop there, you have been showing, right?
True.
The sensor consists, in order to be fed the energy from the outside, it has to have a loop, and that loop is heated.
true.
And there's no way of not avoid it, because otherwise you will violate the second law.
The mouse has a circulatory system which cools down such a.
So it also has a refrigerator injected. I mean, it has a
You also have the same system.
yes, but the mice, this system works normally. It cools the brain and keeps the temperature of the brain
But
in a. Can I complete? I mean, the term. This is a normal situation. All of a sudden, you inject in your brain or a brain of a mice a little loop, which locally is heated. And I'm asking what is the reaction of the brain, of the system, of a neural network, to the fact when mechanically, not that you heat one part of it, and that heat has to be dissipated somehow, and it is an additional heat to dissipation. And of course the mice system, the cooling system, as you want to say, it's trying to take care about it. But this is not a normal situation, because you usually don't hit the brain.
Sure, Łukasz, but that was checked as much as it can be checked, because of course people don't want to sacrifice too many mice on those experiments. This is another point of view. It's a very difficult and delicate situation, but additional heat source was implemented into mice brain of efficiency, so to speak, or power output of a similar magnitude, and behavior of mice was investigated, and no visible changes were found. And that's as far as we can go.
So that's the answer to the question I'm giving. The reason why I ask is that
Those
there has
experiments
been-
were not
that
very
there-
comprehensive
in
on
addition
another point of view,
Yeah.
because each such experiment ends with the disease of the animal.
Yeah, but there are millions of
True.
this exaggeration. There are lots of experiments on heating localized neural cells, not in the mice but in the humans, done by people working on the cell phones. Because one of the issues is that if you carry the cell phone, you are heating the cells in your ear and around it, and also in your brain, by two ways. And that is about the cooling system of the natural one. When that one is that you feed electromagnetic radiation into those cells, and the other that there is a lack of ventilation, because you screen that part of your skin from the environment. You screen it by giving it the heat.
yes, but first of all, the coil is not installed on the brain; it's installed on the back of animal.
there
It
are
does not hit the brain at all.
there are three separate parts. I may
And
comment.
the second thing is that we use very low frequency. That it's actually it does not hit the issue. We expose the tissue to levels of tens times higher power, and we don't observe any.
Power is very low.
Yes, the power per mouse is a milliwatts. If you compare the power generated by mouse itself, it's tens of orders of magnitude.
We are talking, but we are talking about the differentials. It's an extra.
And
I'm asking, because you said you measure it fine.
Łukasz, but this is not a one-parameter system. It's a living animal.
I know.
Yes,
I'm also
there may not
so
be
far.
a window in which you can slip into and enter the realm of effective optogenetics, because the power which is accepted by the mouse is
But
too high and it's necessary to power these devices to high. However, in such a system, unless you try, you will never know.
Yeah,
And there are millions of other factors
then
which
my
can prevent
question-
it from working. And the only
The
way is
reason
to
why I
try.
was asking is that also the power which you put in addition via these light-induced signals is also very low. And I mean, there were no numbers given, so I don't know how this additional power fed into the animal by shining that light on the light-modified connection in the neurons is related to the change of the localized changes of energy due to the just electromagnetic field fed into the animal. The answer apparently was given to me now is that there is a huge difference, that this light is more important
You can
than
use
this.
pulses. You don't have to shine continuously, but you can use pulses.
There is a millisecond pulse.
The amount of absorbed power by a factor.
So there is a gap, an energy gap between the how much energy are feeding into the animal brain by the light and
Yes.
by the power in the coil, and that would answer my question.
Yeah, that's okay.
And that is as far as I can understand it. I think it's a legitimate question whether these energies are similar. So there's no point of being so excited about this.
It's
Right.
because it's exciting.
Yeah, just to add a comment about what Greg has said and to answer your question, what has to be put in the brain of the animal is the light-emitting diode with the IGLIS, so-called cannula, and it is the only device that needs to be put to the brain. Now, considering the implant and the coil, they can be mounted, these three devices, and they can be mounted separately in different parts of the animal. The point is just to wire the coil and install it in the brain.
That particular point I was missing from the presentation.
But it's also true that if you have to wire them together,
Somehow.
this is a chemical environment with
which is affected.
complicated chemistry, and some of those wires can be eaten, and if you cover them with something to prevent, it can interfere with the chemistry of the animal, and therefore it's an endless list of problems. The
True.
only point is whether we can manage somehow to measure prototypes
This is a
and show that it's
fascinating issue
working,
which
True.
people
and
are
then try
asking.
to improve for the next 10
Absolutely,
decades.
True.
that is the point. I mean, this seems to be extremely interesting experiment. The question is only to understand, to find out the loophole in order to make it really reliable.
We are undeniably dealing with
And
trade-offs.
These experiments, I mean, there's a very simple experiments several doctors are doing, measuring the conduction and so-called latency of a nervous system in your legs or hands or whatever. And that is where they put, that is strongly affected by any chemical change on your skin, for example.
True.
So this is extremely tiny little difference because it's so, as you mentioned, it's so multi-dimensional system. And you can only control a very few parameters in it.
Actually, we did tests, thermal tests on the mouse. So we induced some heating.
Excuse me?
So we induced some heating component to the brain and the temperature sensors, and the mice are very resistant to the heating. We're able to deposit 300 milliwatts of power. It's 10 times more than we needed. It was only half degree of temperature change because of the circulatory system of the mice, which cools, which is very efficient. The brain is the most cool organ,
Yes.
and no anomalies in the mouse behavior was observed.
Thank you.